What's up, data junkies? Alex here from King Cloud Consulting, and today's video will be on making sense of a whole gaggle of data terms that are often overused, interchanged, and generally not very understandable. Those terms are going to be database, data warehouse, data lake, data lakehouse, data mart, data vault, data mesh, and data fabric. A lot of terms that are thrown around, some of which are commonly known, others are not. Some are expected to be commonly known, and maybe you're not sure exactly what they are. This video is going to wrap up all of this. If there are any words that I missed, let me know down below. I can make a separate video on them. But without further ado, let's actually get into the meat and potatoes of it, which is making sense of what the heck is going on here. Now, I'm going to take our screen out here, and we're going to start with the most common one, which is the term database. Now, database is really a storage platform of sorts, or a storage unit where we can store our data. That data usually comes in two forms. More often than not, it is what we call structured data. So think tables with rows and columns. More often than not, when someone is storing data in a database, they are storing rows and columns of information. So this is usually denoted by a kind of a symbol that looks like this. And within it, we've got a whole collection of different tables, right? We can have a table on customers, we can have a table on products, and so on and so forth. Databases have been around for a long time, and traditionally they've been used to hold what are called transactional records. So transactional record means something happened once. Think about a transaction. If I had a list or a table of all transactions that have happened across my company, well, these can be stored in a database. And that table, there may be a table called transactions, and maybe a supporting table called customers, and so on and so forth. That's all I'll really say about that. Because really what I want to contrast it with is this next term that has come up over the past, maybe it's a 21st century thing, which is this concept of a data warehouse. Now, for all intents and purposes, in using layman's terms, the database and the data warehouse are very, very, very similar. They have a pretty similar use case, with one slight nuance, which is the fact that data warehouses tend to be a lot more powerful. So maybe I'll draw like a similar database and with like a plus plus. Now, on a purely technical side, at least one major difference between the two is the fact that they use a different engine, a different way of computing information. The database uses traditionally what's called OLTP engine, and OLAP or OLAP is what data warehouse uses. The details are not really important for just understanding the concept and the difference in the two. If I was to say when I'd use one versus the other, if I really had to make a choice, gun to my head, it's like the database is really if we want to store large amounts of data and not do much with it. Right? Maybe we need to pull information, we kind of select star, we gather information out of it, we want to extract stuff, and that's it. We're really just keeping data. If we want to not only keep data, but do a lot of analytics on it, do a lot of heavy reporting, do a lot of heavy computation, that's where data warehouses come in. So they're actually structured the same. They're also comprised of a whole bunch of tables, but the idea is they're a lot more powerful. So, in 2025, when this is being recorded, compute power is not really a problem like it used to be. So we're kind of spoiled in that we don't need to think about compute for a large majority of use cases. This used to be a problem though. If you wanted to take a large amount of data in a database and do heavy computation or analytics on it, you kind of get yourself into trouble because you might just run out of power. That's hard to do with data warehouses. They can really scale a lot. And so most companies now have bought into the data warehouse bandwagon, which is to say, I'm going to pay for Snowflake, I'm going to pay for Redshift, I'm going to pay for any of these larger data warehouses in order to get this supermassive compute. In a lot of cases, it's not needed. There are definitely many cases where it is, but it is kind of like smashing a ladybug with a sledgehammer in some cases. It is more expensive. You're paying for that compute. For all intents and purposes, on a day-to-day basis, most people use them interchangeably, and I get it. I'm guilty of that as well. And it's really not a big deal, but the difference between the two technically, as far as I'm concerned, is really the amount of compute power available. If you use them interchangeably, super not a big deal. Now, where things start to deviate a bit is with the data lake. So the data lake is an even newer concept. I think this is like a 2010s thing, but don't quote me on that. You can correct me in the comments if I'm wrong. Maybe we'll denote that with a little lake here. I've seen it kind of drawn like this. Now, a data lake is also for storage of data, but it's typically used for storage of unstructured data. So what do we think? Like unstructured data is, for example, music, right? It could be videos. It could be, in fact, the really the kind of the easiest or the simplest example I usually give of the data lake is your Google Drive, right? So if you think about your Google Drive, you could store CSV files in there, so you can store, I guess, structured data, just chuck it in. You can store images from vacation. You can store your favorite songs. You can really chuck anything you want in there. You just throw data in, and that your personal Google Drive, as far as I'm concerned, is an example of a data lake. Now, at an enterprise level, if we're talking security footage from our cameras, if we're talking some companies are collecting, I don't know, I'm guessing DNA, the whole 23 and Me bankruptcy is a hot topic right now. I'm guessing DNA storage and collection is also dumped in some sort of data lake. So it's information that doesn't really fit in a table per se. It doesn't necessarily fit in a structured format. You can kind of dump it all in there. That's really the purpose of a data lake. Where we're seeing more and more use cases for the data lake is really in the fact that we're now meshing structured with unstructured data. So we want to take unstructured data like sounds, break it down into fundamental components, and do some sort of computing on it to create a machine learning model that can help us create other sounds. And we're using it a lot for I'm sure AI uses it somehow under the hood, not my area of expertise, but nevertheless, the idea is we can take unstructured data, break it down into its component parts, and then do something resembling structure with it. This is why we'd want to keep a data lake, right? S3 buckets, I'd argue, are another example of a data lake, if you know what those are. That's the idea. So maybe I'll make a note here. Maybe we summarize this at the end. Databases are really for structured data more often than not. Traditional databases, you can also have semi-structured sometimes. We're not going to get into this much. Those of you familiar with like MongoDB, you can store semi-structured data. Still considered a database. It's a NoSQL database, but database nevertheless. Data warehouses, typically we think of really this is for structured data. You'll forgive my messy handwriting. And then we've got unstructured data for the data lake. Now, as the years go on, we've also got this newer concept coming out, which I'm hearing a lot of, and it's really the data lakehouse. If you'd like to pause the video, have a guess as to what that is. But really, this is two things. This is a combination of data lake plus, say it with me, data warehouse. So I'd argue that the team that really popularized this would be really, we think Databricks when we think data lakehouse. And Databricks is a platform that allows you to really store all your data in one cohesive spot, and that is structured, semi-structured, and unstructured data can go into the data lake. As well, they have a compute platform on top of it, so they can help you manage that. They also allow you to write code and scripts and what have you, and automate things on top of all this data. So if you think one unified spot where I can do computational work, data work, analytical work on top of structured, unstructured, and semi-structured data, that is a data lakehouse. Fundamentally, if you understand how to work on structured and unstructured data separately, this is just kind of like a nice to have. It's like, cool, I'm putting it all in one spot. Once again, though, this is something that you're paying a big premium for because it's all in one spot. And in a lot of cases, that makes sense, right? Maybe the savings of paying for a premium data lakehouse like Databricks outweighs the total cost of ownership of having these other fragmented technologies and trying to integrate them all together. That's neither here nor there, though. Really, the point of this video is to say how do we make sense of these terms, and that's what a data lakehouse is. I'll make a little note here. This is really for I'll call it all data plus compute plus. We can do all our analytical work on top of this quote unquote data lakehouse. A few more terms. Next one we're looking at is going to be a data mart. The first four that we looked at were really terms that summarized where we're storing data as a whole for the most part. These next four terms are going to be a bit more on the logical and semantic side, not so much about actual infrastructure and storage. Now, a data mart is a term that, as far as I'm concerned, has one pretty strict definition, but then it's almost taken and used in different business terms, which is fine, right? That's how these words evolve. But more often than not, and at least how I use the term data mart, is this is going to be a consumption layer within a database. So what the heck do I mean by that? Well, think about a database. And if you're a data analyst, when you're receiving data, when you're using data for a Power BI report or an Excel report or any other report you're building or dashboard, you are typically using data, hopefully that has been cleaned up and prepared for your work. That's the goal. That data that you're accessing is what we consider a data mart. So I'll give you an example. Let's say that we have a Salesforce instance. That's my horrible cloud. I've got Salesforce, and we have some sort of data pipeline that's pulling data from Salesforce into our central data warehouse. Usually how these things are designed is within the data warehouse, we don't just have tables sitting around. We have tables broken down into typically what are called schemas. Imagine I've got this one schema, and within the schema, I have many different tables. Now, I've got maybe what I'll call my raw schema. Within the raw schema, I'm dumping raw data. So I've got multiple different tables here, one for customers, one for products, and so on and so forth. And this is raw data. So I ingest it the way that it exists within the source itself. That's how I'm ingesting the data. That raw data might be of very little use to a data analyst or to a team that's that's likely to be using this data. So often what data engineering teams will do is they'll take the data from the raw schema and they'll put it, they'll maybe go through multiple steps of cleaning this data, and eventually they will end up creating what is called a data mart. And that data mart is really maybe what I'll call clean plus combined data. Maybe you've got a use case where you have to combine both the customer and the product data, and so you want it all in one spot. Well, data engineers might clean that data, they might stitch it together and make it available to you and say, hey, when you're connected to database, just use this URL, use this set of credentials, or click on this data mart name over here when it pops up, and this is what you have access to. Again, more often than not, if you're a data analyst, if you're a BI user, you are probably getting access to this data mart, and you are probably not getting access to the raw schema, probably if things are designed properly. So the data mart, as far as I'm concerned, again, is really a consumption layer of clean data, right? So I'll say a consumption layer of clean data, right? Uh, Data market is another term that's kind of been, this is that's broken off. You take a data market, usually it's just data mart level data that someone's like made available to others, maybe to sell it on a marketplace like Snowflake offers, kind of selling prepackaged data. This all follows a similar notion. So I think I'm going to leave the data mart piece here, but when you hear this term, that's what we're talking about. It's that final consumable, clean, joined data. Uh, Data Vault is another one. This is one that I've heard kind of on and off over the years. Uh, you're usually going to hear this a bit more in data settings, maybe not so much when you're on the analytics side, maybe more on kind of the engineering when we're deeper down in the data, but nevertheless, it was worth mentioning. Data Vault is another, it's really a data modeling technique, right? So it's a data modeling technique. And within this technique, what we're doing is we're saying, what is uh, what is kind of one intelligent way to store raw data? So usually I'll say this is for raw data. And again, this is a conceptual overview. It's a way that I decide to store data. It's not infrastructure, right? It's not a specific object. There's no one thing that definitionally forms a data vault, but it's saying if I store my raw data in this one repeatable pattern, it's typically what we call the data vault pattern. And at a very high level, what you've got is you've got this concept of a hub, and you can think about a hub as a table. This table has different what they call satellites, right? Satellites. And those satellites give you more descriptive information about that data. So if you're familiar with star schemas or snowflake schemas, really, it's kind of like a fact and dimension table similar. And then I've got multiple hubs, okay? And we need some way to relate those two. And the relation, where we store the relationship between those two, is what we call a, oh boy, we call a link. I'm not going to go into more detail here. I don't want to make this a data vault video. If you take away the fact that this is a data modeling technique usually used for raw data, that's good enough. With the with this kind of data vault structure, what you've then done is you've set yourself up for success to then be able to clean and join the data further up into closer to consumption layer schemas. So for instance, there's a very real possibility that your data engineering team might be storing data in some sort of data vault-like fashion, and then they clean it and prepare it into a data mart for you to consume. So in that case, you really only care about the data mart, but under the hood, we've used this other data modeling technique to store raw data. Final piece on the data vault is it's a very good technique for when we want to store historical data so we can see how data has changed over time. It kind of takes into account that the change data capture and historical changes. So something to keep in mind. Again, I'm going to cut this here. I don't want to go any deeper. I think we've explained roughly. I've explained roughly enough to make sense of this concept, I'd argue. Okay, two more. Data mesh. This one is increasingly popular because I believe the term data mesh, it was coined sometime in the late 2010s, as far as I'm aware. And the data mesh is not really a data modeling technique. It's not infrastructure. It's not storage. This is a logical organization of data. I'll call it data operations, right? Maybe that term's a bit loose, but really, if you can wrap your head around the fact that this is a logical organization of how we use data within an enterprise. And I'll give you an example. This is how we decide to quote unquote decentralize data. Okay. So in a traditional data model, in most companies, we had what's called the hub and spoke model. You got one data team, and that one data team supports HR, it supports legal, it supports ops, right? It supports whatever I'm missing, finance, so on and so forth. We have one central data team, and they start providing data services, data availability, and everything else to the rest of the organization. Great. This model, the hub and spoke model, has been kind of depopularized. I think it's been a bit demonized. I think that the hub and spoke model makes sense for smaller teams and smaller companies. At scale, this starts to fall apart because usually what happens is you have a lot more requests than a data team or a BI team can actually handle. So how do we find a way to split the ownership and the responsibility of data across the organization in a responsible way? That's what a data mesh is. So again, this is a logical grouping of how we split responsibilities. Maybe data responsibilities is a better term. Of how we split responsibilities. Spelling is hard, man. I'll tell you. Can't walk and chew gum at the same time. All right. Logical organization data responsibilities. If we tweak this slightly, we can rearrange this, and that's kind of what we end up calling a data mesh. Now, in a data mesh, we almost axe this concept of just one central data team. What we do is every team becomes its own almost hub, if you will, or its own node. Maybe I'll call it a node, so we're not confusing with the data vault. So everyone is responsible for their own data. If finance needs HR data, they can communicate. If legal needs finance data, they can communicate. You can imagine all these different communication channels. The more nodes you have, of course, the more communication paths there are going to be. And really what's happening here is the fact that every team owns its own data as if it's a product. And so there are certain criteria you have to meet to be a data mesh. There are great videos on it out there, so I won't go through it exhaustively. One of them is data is treated like a product. So finance owns the finance data and is responsible for the finance data. HR owns HR data and is responsible for the HR data, et cetera, et cetera. So data ownership is decentralized. What is centralized typically is the architecture, the data governance, who's allowed to do what, or who's allowed to see what. I take that back. Data governance, finance says is HR allowed to see the data, yes or no. The central architecture piece is kind of what softwares are we using? What sort of infrastructure are we going to use? How are we building data pipelines? What patterns must everyone follow, naming conventions and stuff like that. Incredibly important stuff to make sure that this data mesh actually works is that underpinning, that foundation. That part is still centralized, and that'll be centralized by either an IT team, a data architecture team, maybe still a data team. It really depends. It could take on different names, but this is a high level idea of what a data mesh is. I've seen companies implement a data mesh and call it by some sort of like a pet name. They don't really call it a data mesh, but again, if you've seen this sort of organization of responsibilities, this is a data mesh. Again, it's not a product, right? It's not infrastructure, it's not a technology, it's a way of organizing data responsibilities through an organization. Again, a lot of great videos on this. If you want to go into more depth, they'll explain kind of the firm definition of the data mesh. Now, finally, I've got the last one, which to me is, I think it's the least powerful term. It's also the most ambiguous one, um, and that is data fabric. Data fabric is, I'd argue, it's really just the concept, right? It's some sort of concept. It's a loose descriptor. It's the flimsiest definition of all these terms, and it's used in a few different ways, primarily two, as far as I'm concerned. So before May 2023, this was really used. The term data fabric was used to describe maybe I'll call it the entire data ecosystem of a company. All right, so what do you mean by data ecosystem? If we talked about your data infrastructure and the architecture and the governance and the security and the technologies we're using and how we're storing information and how it's split and all of that collectively, how it all interacts and lives together as one big massive beast, as far as I'm concerned, is what we refer to as data fabric. Again, it's a loose term, and I'd argue there's not much meaning in it per se, but as far as I can tell, based on research that I've done, this is the close, most succinct definition I can give you of a data fabric. Now, from May 2023 onward, although this could still hold, right? So maybe this is still how some people use it. But in May 2023, Microsoft came out with this term data fabric, and as far as I know, they started selling this package of Microsoft offerings as data fabric, as what they call data fabric rather. So this is Microsoft packaging of services. So this kind of, since Microsoft is so big, they almost get to almost monopolize certain terms, and that doesn't need to be intentional. But what they did was they said, we're going to package a bunch of offerings that we already have within the Microsoft ecosystem, and we're going to call it the data fabric. So when a customer purchases the data fabric, they're getting all this different software, and it's interacting and it's playing super nice. So now when you hear the term data fabric, someone might be referring to that Microsoft offering, right? Again, especially if it's coming from the Microsoft team. It could also, however, still refer to this piece here, this entire data ecosystem of a company. Again, it could go either way. This is a very loose term. I'm not really fussed about this one. I don't think it's used too frequently, but I've heard it often enough where it warranted inclusion. So if it still has some ambiguity, I get it. Best thing you can do is ask. If someone says, we had a client once ask something similar about how does this fit in our data fabric? And it's like, what do you consider your data fabric? And sometimes people have a clear answer, other times they don't, right? So if you're unsure about these words or any others, you ask. I'd usually say you Google and do some research, which you should, but at the same time, a lot of these terms are still ambiguous, right? You Google data fabric, you can get a lot of different answers. So don't be afraid to ask. A lot of people use these terms interchangeably. And again, this was just, I wanted to make this video to make it a bit more dangerous when you're in meetings and conversations and want to hold your own and really make sense of what these words mean. With that, we'll wrap this video up. I think we're going on 20 some odd minutes and no one wants to hear me ramble on anymore. At this point, if you have any more questions, any terms I missed, any corrections or caveats you want to add, drop them in the comments. Contact is in the description as always, and we'll see you guys in the next video. Take care, y'all.